In the name of Almighty God, the most compassionate and the most merciful, I mean Bismillahir Rahmanir Rahim. By the way, I welcome you all to your own channel, and today we will have and discuss our second lecture on chapter 1 of trigonometry. I mean lecture 1.2. In previous lecture, we described and we discussed on trigonometric ratios, sine, cosine, tangent, and like this one. And we mentioned that the reciprocal for the sine is cosec, reciprocal for the cosine is sec, and for tangent is cotangent. And one thing I have to say, whenever you're talking about sine alpha, and I mentioned in previous lecture that sine with alpha, they are not in multiplication case, but both of them are one term. I mean that instead of alpha, if we don't have alpha, if we separate alpha from the sine, there is no meaning for the sine. Now, whenever you want to write sine alpha, for convenience, if I write sine alpha whole square, this one also I can write sine square alpha. They have both same meaning. But this is true. But if I write sine alpha to the power minus 1, it is not true that sine minus 1 alpha. This is not correct. Why? This one gives another meaning and this one gives another meaning. This one, when I write sine alpha whole to the power minus 1, it means 1 divided by sine alpha, or we can write cosec of alpha. But this one, sine to the power minus 1 alpha, this is called arc sine. This one is called arc sine alpha, or we can say sine inverse of alpha. We will study such things in much later of the trigonometry. When we finish trigonometric, I think in the last chapters we will study about the inverse function of the trigonometric ratios. But we can write sine alpha whole to the power minus 2. This one can be written sine to the power minus 2 alpha. This is correct. But just for sine to the power minus 1, it's not correct. This one gives another meaning and this one gives another meaning. These are the things that we have to describe, and it was related to the first lecture of the trigonometry. By the way, we will start our lectures today from the angle. I start the trigonometric from very basic parts, and we will have, inshallah, by the mercy of Almighty God, up to advanced level of the trigonometry. By the way, please find a place and pick up your notebooks. First, you have to listen what I lecture, then you can write on your own notebooks. By the way, whenever you're talking about angle, what angle is? Angle is if I have a ray, this is a ray, it has an initial point, and now I want to rotate this ray about a special point or a constant point. This point, if I rotate this ray, it can be anti-clockwise or it can be clockwise. Now, if I rotate this one anti-clockwise, so this is called OA is the initial point. This one is called initial site. Initial site. Now, if I rotate, it will move up to point B. This is called final or terminal, whatever you want to say. Final side, or you can say terminal side. Now, whatever is making between these two straight lines, whatever is making between these two straight lines, this one is called angle. And we can show this one by alpha, beta, gamma, A, B, C, whatever you want. For example, angle alpha. This is anti-clockwise or clockwise? I think this is anti-clockwise. If your angle is anti-clockwise, it is taken as positive. If your angle is anti-clockwise, it is taken as positive. And one thing I have to say, this point is called vertex. This point is called what? Vertex. I think this is E. If I make any mistakes in spell, then sorry, please. By the way, this is called vertex. This is called our initial side. This is called our final or terminal side. Whatever is making between these two, this is called what? Angle, and hence it is anti-clockwise. It's taken as positive. But if I have, this is our vertex O, this is A. Now I will rotate this one clockwise. So this is the final point. This is initial, and this is final. Now the angle is rotated clockwise. If it is clockwise, it is taken as negative. I mean, this is not alpha, but it is negative alpha. In trigonometric, in trigonometry, we will study anti-clockwise, not clockwise. And we have a relation between anti-clockwise and clockwise. And we will have a lecture on this one in our upcoming lectures. I mean, in trigonometry, this is the four origin we have, or the chord system. Now, if I put the what? The angle here, the vertex is put it in this origin. This is our A, initial side. Every angle that you want to calculate in trigonometry, they are taken as positive. I mean, they are anti-clockwise. If they are anti-clockwise, this is called first origin, this is called second origin, this is called third origin, and this is called fourth origin. Now, if I ask you, if the angle is in clockwise, now the formulas are changed. But we will have, inshallah, a relation between the anti-clockwise and clockwise. Now, what that relation is, we will study in the upcoming lectures, inshallah. Write it, please. We will have one thing more, that this angle is called alpha. Now, what is the measurement for this one? Write it. I will talk about. Measurement of the angle. Of an angle AN. Whenever you're talking about measurement of an angle, in trigonometry we have two measurements. First is called degree measurement, and second is radian. Now, what is degree measurement? By the way, if I have an angle OA, and we want to rotate this ray about one rotation. So we will have this one. Wait a moment. We will have one circle or one rotation. Now this is our vertex point and the center of the circle. It is OA. Now I will what? Rotate this ray anti-clockwise, and we will divide this circle to 360 parts. One of these parts, which is OA up to B, this is our angle. Now this is one of the 360 parts. This is called degree. Now what 1 degree is? 1 degree is 1 upon 3/60th of a rotation, or maybe a circle. Am I right or not? Yes, completely. If we divide this one up to 4 origins, now 360 to 4 origin, it is called 90. I mean, every vertical is what? 90 degrees. Am I right or not? Yes. One thing more, that if we, this is our 1 degree. This is our 1 degree. Now, if I divide this 1 degree to 60 parts, how many parts? 60 parts. One part of this 60 parts is called 1 minute. If I divide 1 degree to 60 parts, one of these 60 parts is called 1 minute. The symbol is this one. It is what? 1 divided by 60th of a degree. Now this is our minute. If I divide this minute to 60 more, this part is called 1 second. What is 1 second? 1 second is 1 divided by 60 of a 1 minute. Now we can have the conclusion that 1 degree is divided into 60 minutes, and 1 minute is divided into 60. This is 60 minutes, this is 60 seconds. So we can say that 1 degree is divided into 3,600 seconds. Am I right or not? Yes. This measurement is called degree. Now, what radian is? Write it, please. Our second measurement is radian measurement. Now, what radian is? If we have a circle, this is our circle, this is our center O, and the radius should be 1 unit. Radian should be 1 unit. What do you mean? 1 centimeter, 1 feet, 1 foot, 1 inch, 1 meter, 1 kilometer. It should be 1 unit. This is our A point on the circumference of the what? Of the circle. Now pick up 1 unit arc on the circumference of the circle. This is also 1 unit. Am I right? The point is B. So I will have another radius which joined the O and B point. This is our radius, which is 1 unit. Now the angle subtended here, it is called theta, and it is 1 radian. Now what radian is? 1 radian is the angle subtended in which its arc is 1 unit and radius is 1 unit. If the arc is 2 unit, it's 2 radian. If the arc is half unit, this one is called half radian. So we can say what radian is: the angle subtended in which the arc and radius of the circle is 1 unit. So this theta is this arc divided by what? Radius. Since arc is 1 unit and radius is 1 unit, so this 1 divided by 1, it's called 1 radian. If I want to talk about the whole circumference of the circle, how many radian it is? So for whole circumference of circle, we can say that whole circumference should be divided by what? By radius. What is our whole circumference for the radius? It is 2 pi r. From geometry, you know. Now, how many radian it is? It is 2 pi r divided by arc is 2 pi r. I mean whole circumference. Arc is in this side, this one is. But for whole circumference, it is whole circumference. And whole circumference, it is what? 2 pi r. Divided by radius. And radius is r. R is 1, it's cancelled. So we can say that it is 2 pi radian. 2 pi radian. One thing I have to say is, which is so important, that is the notation which we use for degree and radian. For degree, if I write alpha this symbol, it means that this angle, its unit is degree. But if I write just alpha, it means it is measured with the radian. This one is radian. There is no symbol usage, but this one is degree. If I write, for example, 2 degree, this is degree. But if I write 2 for the angle, so you have to know that this one is in radian system. I think you have got. Write it please. We will go between the relation of the degree and the relation of the radius, and then we will talk about relation of the radian with the real number line, inshallah. Write it. Relation between degree and radian. In some books we have 3 measurements. Another measurement is grad, but there is no usage for the grad. For this result, in our syllabus we will talk just on degree and radian. One thing I have to say, in nature degree is not correct, most in physics measurement. If you want to talk about an angle, you have to talk on what? You have to talk on radian system. Why radian system? Why not degree system? Because there is a relation between the radian and the real number line, and we will talk inshallah. By the way, relation between degree and radian. Now, you know, in degree we have a circle. Yes, this circle is divided into how many parts? This circle is divided into 360, and each part is called degree. Now, you know, in a radian we have the same circle. In the same circle, it is divided into how many parts? In which this is 1 unit, the arc is the arc, and the radius should be same. If you divide this one, if you divide such things in which the arc and radius are same, it would be divided into 2 pi radian. And you know that there is no symbol for writing the radian. Since they are the same rotation, the same circle, in every circle, for example, this is a small circle. Now, if you divide this one with this one, it should be equal. You will have 2 pi. 2 pi means 2 times 314, approximately 6.28. What does it mean? It means if you divide this circle in which the arc and radius are same, you will have 6.28 parts. This is 2 part, this is 3 part, this is 4 part, this is 5 part, this is 6 part. Now we have a remaining in here, which is 0.28. So how many parts do we have? 1, 2, 3, 4, 5, 6, 6.28. If we have such circle in which the arc and this one should be same, once again you might have the same. How many parts do we have? 1, 2, 3, 4, 5, 6, and this part is 0.28. How many parts do we have? 6.28. It is not equal 0.28, but it is 2 pi. It is 2 pi parts. 6.28 something. Why? Because the value for pi is not 3.14, but approximately it is. So I have to say the circles are same. In every circle, if you divide this circle into 360 parts, one part is called 1 degree. One part is called 1 degree. And if you divide the whole circle or rotation into 2 pi, it is called theta radian. What is degree? 1 divided by 360 part. What is radian? 1 divided by 2 pi. 2 pi means 6.28. One of this 6.28 is called 1 radian. Now you can multiply both sides by 2. You will have d divided by what? 180 is equal theta divided by pi. This is our relation between the degree and what? Theta. Relation between degree and theta. If you have the value of theta, you can find degree. If you have the value of degree, you can find theta. And how many variable do we have? We have 1 variable. Else you will have this value or this value. Both values are not variable. So what the power is? 1. Then we can say that it will make a straight line. It will make a straight line. And one thing I have to say, there are some angles that you have to know in radian. What are those? Those are, this is our degree system, this is our radian system. If we have 0 degree, it is 0 radian. If we have 30 degree, it would be pi divided by 6. And if you have 45 degree, it would be pi divided by 4. And if you have 60 degree, it would be pi divided by 3. If you have 90 degree, it is pi divided by 2. How did I find here these values? Just put here. If you put d30 and you have to solve this one for theta, it would be pi divided by 6. Am I right or not? We will discuss inshallah in the next lecture on the best examples. And if you have 120 degree, it would be 2 pi divided by 3. If you have 135, it would be what? 3 pi by 4. And if you have 150, it is 5 pi divided by 6. And if you have 180, it would be pi. You have to memorize this value. What 0 degree is? 0. What 30 degree is? Pi divided by 6. Mostly we will use 95% these values: 0, pi divided by 6, pi divided by 4, pi divided by 3, and pi divided by 2 in our example. Mostly we will use. By the way, if you cannot memorize this one, you can put the values here. Put it and you will find inshallah the what? The value. And one thing more, that 1 radian is what? 1 radian is 1 radian, just d divided by 180 and theta divided by pi, in degree I mean. So it would be d divided by 180 and theta is 1 divided by pi. Put this 180 here, so you will have d is 180 divided by pi. D is 180 divided by pi. What is pi value? Pi value is approximately 3.14. So it would be 57, I think. 57, 1.17 or something we have. This is our 1 radian. This radian is about 57 degree. And if I say 1 degree is in radian, so once again you have to put here 1 divided by 80 is theta divided by pi. So theta is pi divided by 180 and pi is 3.14 divided by 180. Theta is, you have to divide this one, it's 0.0017, I think, radian. Maybe you have to divide 3.14 divided by 180, it is 0.0017. I don't know, 0.017 or 0.17. You have to do by your own self. Write it please. I'm sorry, this one is 5732 and this one is 0.017, not 00. 1 degree is 0.017 radian. In radian we don't have any symbol, but 1 radian is 57.32 degree. Write it. Relation between radian and real number line. What this one says, if I have a circle, if I have this one, it's not a circle, it's like a potato. I'm sorry. Now I'll try myself. I think it looks. Now this is our center O and this is A point and the radius is 1 unit. This is also called trigonometric circle. If I want to say what is trigonometric circle, trigonometric circle is the circle in which what? In which the radius is 1 unit. Now in here I will make a tangent line. This is our tangent line. And A point is the 0 point of our this tangent line, which is called real number. And we have, this is 1 unit, this is also 1 unit, this is the same 2, here we have -1, and here we have -2, up to minus infinity, and this is up to positive infinity. Now what do I want? I want this side, which is O, suppose B side, and this is C side. I want, what do I want? I want to rotate this part OB, or this is A, I think A, and A is the 0 point of our real number line. I want to rotate AB side anti-clockwise to this circle, and the AC side clockwise to the what? To the circle. Now what do you think? This one, if I rotate this one is in here, am I right? This 2 is here. So now what do you think? A up to 1, is it arc? Yes, I mean that arc is 1 unit. Since arc is 1 unit and radian is 1 unit, the angle subtended here by name of theta, this is called what? 1 radian. For this result we can say that the relation between radian and real number, that they are same. Real number and radian, they are same. If I want to say 1 radian, I mean 1 unit in real number. If I want to say 2 radian, it is 2 in real number. 3 radian, it is 3 in real number. -1 radian, it is -1 in real number. -2 radian, it is -2 in what? Real number. Pi radian, it is pi in real number. √2 radian, it is √2 in real number. So we can have the conclusion that the real numbers and the what? The radian system, they are same. For this result, in calculation, we have to use mostly and 100% in nature problems. I mean in experience you have to use 100% the radian system, not the degree system. I think you have got. Write it please. By the way, we have to close our lecture for today. For the next lecture, I mean for lecture 3 of this chapter, chapter 1, we will have our great examples on the what? On the conversion of the degree and radians, inshallah. And we will talk about the signs of the trigonometric ratios in 4 origins. Love you all. Support me please. Please. Allah Hafiz. Goodbye.